just share my screen. Okay. So I I hope my screen also is visible, right?
Yes, sir.
Okay. Okay, thank you. So today I'll be conducting the problem solving and doubt clearing session for this for the course Electrical Measurements and Electronic Instrumentation, which is taught by Dr. Abhishek Chatterjee. So I am a TA for this course, and I'm Calvin Joseph, and I'm a third year research scholar from IIT Kharagpur. So my sessions will be held on Monday between 6 to 8, and these sessions will be recorded, and the video will be uploaded as well as the notes which I write. They'll also be uploaded on the drive, so you can access them later as well. Okay, so some guidelines is like during these sessions, yeah, if you want it to be as beneficial as possible to you, I'd advise you to remove distractions like remove phones or other stuff, so that it is good for you. As well as you should keep us some notes, some notebook with you, and you should take some notes, like whatever is being taught in the session. So what I will do in my session is first I will I will take a brief recap of what was taught by the professor during the week. That is today, week one I will take. Then after conducting that summary, you can ask your doubts, and then we will proceed to solving certain sums. Some example sums we will solve. So you must have a pen as well as a calculator with you for solving the sums. And you can ask questions. You can unmute and ask me questions for whatever doubts you have. As well as it would be good if you would keep the session interactive. So once you're interactive, I will get real-time feedback whether you're able to understand the concept or you're not able to understand a concept. And we can proceed in that manner. All right. So I have conducted NPTEL sessions in the previous year as well as 2-3 times I've conducted. So the sessions are fruitful and enjoyable for the students as well as to me. When you ask your questions, when you have your doubts, and when you want to clarify certain problems or certain difficulties. Okay. And it would be good if you can keep it interactive. So today in our session, we will consider what are electrical measurement instruments, why do we need them, as well as the various types which Sir has discussed. So Sir has discussed 4 types: PMMC, electrodynamic, moving iron, electrostatic. All these instruments we will discuss. Also, the concept of damping. Why do we need damping in these measurement instruments? And also, we will consider what is a galvanometer. And then we will do some example sums we will solve. Okay. So, you guys are able to see this? Hello?
Yes, sir.
Yeah. Okay, thank you. So today we will start with week one. Okay. So in an electrical circuit, okay, I will draw one sample electrical circuit. Okay, so this is a simple electrical circuit. So can you tell me what quantities do you want to measure in this circuit? Like what electrical quantities you would like to measure? So there are 12 participants. Kindly tell me what would you like to measure? What in an electrical network, what would you want to measure ideally, typically? As I said, please be interactive. So you would typically want to measure voltage. You would also want to measure current. Further, you might want to measure power, right? Okay. So to measure voltage, what do you use? Hmm? Okay, so to measure voltage, you use a voltmeter. To measure current, what would you use?
Ammeter, sir.
Yes, you would use an ammeter. And to measure power, what would you use? Correct. Okay. To measure power, you would use a wattmeter. Okay. So in case you guys, as you know, like sometimes we are shy, everything, we don't want to unmute and etc. You can even answer the questions via chat. Okay. So it's up to you guys. And if at all your mic is not working, etc., you can use the chat. For your questions also, you can use the chat, or you can unmute and stop me and ask me. Okay. So now we want to, we want, if in our circuit, if we want to know what are the voltage, current, power, etc., we will use these measuring instruments. Okay. So sir has taught the first measure instrument sir has taught is PMMC. Okay. So can anyone tell me what is the full form of PMMC?
Permanent magnet moving coil.
Okay. So it is a permanent magnet moving coil. Okay. PMMC is permanent magnet moving coil. So as the name suggests, right, there is a permanent magnet. There will be the North Pole, South Pole, etc. Also, there is a coil. It will have various turns. It will have. Okay. And there is a current flowing through it, which we want to measure. Okay. There will be this magnetic field, which is going from your North Pole to the South Pole. Okay. So it is a permanent magnet. So that field is constant. You cannot change it. Okay. There'll be a number of turns. Okay. There will be some length of this. There will be some width of the coil, etc. And sir has derived the expression for the torque. Okay. So when some current I will flow through this coil, what will happen is because the current is flowing and because of the magnetic field around the coil, there will be a force which is generated. Okay, one force to a couple of forces will be generated. So they form a torque couple and it will make your moving coil to rotate. Okay, and that will cause a deflection. Okay, that deflection is given by this formula BANI. Okay, this is the deflection which occurs. Huh? But you must also remember that there will be a spring or sort of spring will be attached to this. Okay, there will be a spring attached. And can anyone tell me what is the role of the spring? You guys have gone through
To
so many.
oppose the motion.
Yes, it will oppose the motion. Okay. We don't want it to just rotate indefinitely. Okay, we want it to come at some particular point. So there will be a spring which will generate a torque that will be given by K spring into theta. Okay. So at the equilibrium condition, we will get this deflecting torque and this torque due to the spring will be equal, and they will be, you can equate them and you will get this formula. Okay, so this is your deflection which is produced. Now, this deflection theta is what is going to be seen on your scale. So suppose you have an instrument, it is like this, okay? This is 0, this is 1, this is 2, this is 3, etc. So this is your theta, how much it is deflected. If it is deflected to this much, means it is at 0.2 or 0.5 something. If it is deflected to this angle, that is this angle, then your current which is flowing is 2.5 or something. So based on the deflection or the theta, you can estimate how much is the current flowing, and that will be shown on your measuring instrument. Okay. So any queries or doubts till now?
No, sir.
Okay. So this is the first type of instrument which sir has taught, permanent magnet moving coil, and we will also solve some sums regarding this. Now, what is the second instrument which sir has taught?
Electrodynamic instrument.
Yes, it is an electrodynamic instrument. So what is the difference between the electrodynamic instrument and the PMMC?
So they have core in it, and the electrodynamic instrument do not have core or something curved center.
Achha. Okay. Well, the main difference. Huh?
In electrodynamic, it has a electromagnet, and PMMC, it has a permanent magnet.
Okay. So why, like, what's the difference between the electromagnet and a permanent magnet? Both are magnets.
The electrodynamic do have coil in them.
Huh. Okay. The main answer I was looking for actually was in an electrodynamic instrument, the field or the magnetic strength is dependent on the current which is flowing through your electromagnet. Okay. So let me go to next page. So in an electrodynamic instrument, you're replacing the permanent magnet with an electromagnet. Okay. Yes, yes. So suppose there's some current. This is your fixed coil, okay? A fixed coil is there through which current is flowing. And there is a moving coil through which current IM is flowing. Right? So typically, okay, so there's a fixed coil, which is your electromagnet, through which when current will flow, it will generate a magnetic field. Okay, there's another coil also in which current flows. And when these two magnetic fields interact, they will generate a torque. Okay, these are mounted on a shaft, pivot, etc. All those mechanical things are there, which I have not shown over here, but they are present. Okay, and then they will generate a deflecting torque. That torque is given by IF, that is the current through the fixed coil, into the current through the moving coil, into dm upon dt. Okay, dm is the magnetic coupling or the magnetic inductance between the fixed coil and the moving coil. So this changes as the orientation of your pointer will change. Okay, in normal scenario, in most scenarios, your IF will be equal to IM. So, and that let us equate that to I. So your deflecting torque will be equal to I square dm upon d theta. Okay, this is your deflecting torque. Now you will also have a torque which is due to the spring, which is K spring into theta. Okay, So at equilibrium position, what will happen? You will equate these two, okay, and you will get I square into dm upon d theta is equal to k spring into theta. Okay. So what is the main difference between the PMMC and this electrodynamic instrument is it is what will the electromagnetic instrument, this electrodynamic instrument measure? Will it measure the average or will it measure the RMS? I think someone already mentioned it. Okay, so Jivan Patil said that PMMC is used for DC only, but electrodynamic can be used for both AC and DC. That's correct. But what in AC, what quantity is it measuring? Okay, it is measuring the current, but it is measuring the RMS value of the current. Okay, it will measure the RMS value of the current, root mean square value of the current. Why? Because it is proportional to I square. Hmm? Okay. Which is the third instrument which sir taught? Yes, yes. So PMMC is linear scale and electrodynamic is non-linear scale. That is correct because I square causes the non-linearity. Hmm? Now, which is the third instrument sir has taught you guys? Okay, so third one sir has taught is the moving iron instrument. So we have a coil through which current is flowing, and there's also some iron bar. Okay, and it will be coupled to a spring, etc. There are certain mechanical construction, etc. is there. So this iron bar can move. Okay, it can move. It can move. So when it will move closer, what will happen is the amount of uh, the permeability of this coil will increase. Okay, that means it can generate more flux because the reluctance offered by iron is less. So it is effectively changing the self-inductance of the coil, and the expression for the deflecting torque is given by I square into dl upon d theta. Okay, so you must remember these expressions because these expressions are the main thing. You must know PMMC, what is the expression for the torque, for your electrodynamic, what is the expression for the torque, for the moving iron, what is the expression of the torque. These you must know. Another thing is, it is deflecting torque is I square dl upon d theta into half. Okay, this is the formula. Similarly, you will consider there's a spring, etc., and the spring will generate a torque k into theta, and at equilibrium you will equate them and you will get the expression. Hmm. Okay. What is the next instrument which sir has taught? Yeah, this is repulsion type. Okay. But the next instrument which sir has taught is the electrostatic instrument. So till now, the instruments which we have, which sir has considered, they will directly measure the current. Okay, they are typically used for measuring the current, but this electrostatic instrument will measure the voltage. Okay, it will measure the voltage. So there are some plates. So suppose there is one stand. Okay, there are two things. There will be something which can move. One plate which is connected to this and which can move, and that is further connected to your spring and your pointer, as well as there is something which is fixed. Okay, there is another plate which is fixed. So depending on how much overlap is there between these two plates, that will change the capacitance, which in turn will change your deflection. Okay, which in turn will change your deflection. And I said something. Yes, yes. In moving ion types, yeah, there are two types to discuss: attraction type and repulsion type. I was just considering basically what was the expression which was used. Okay. Preferably, mostly repulsion type instruments are used. Okay. So for the electrostatic instrument, the torque expression is given by V square into half into dc by dt term. Okay. So any doubts still here? Am I going too fast or too slow, or like what exactly are you looking for in this session? You guys can let me know. Mhm. So you guys have taken this for gate preparation, or you have taken this NPTEL course for your credits which you require in your college, or like what is the reason behind you taking this course on NPTEL? Acha. In the final exam, this will be conducted. Okay. So in the final exam which will be conducted, there will be both numerical answer type questions. Okay. This is numeric one, where there will be a blank and you have to fill in the value. You have some say you have to find the current through this circuit, or you want to find what is the range of a ammeter, etc. something, and you find out that that range is, suppose you say it comes out to be 6.5 ampere, or let us look at a good value, let us say 10 ampere. Okay, so now you have to enter the answer 10. So when you solve sums, etc., you must read the question very carefully. If it is written ampere, then your answer will be 10 ampere. If in the question it was written milliampere, then your answer has to be 110 and another 1000. If instead they had asked for kiloampere, then your answer should be 0.01. Okay. So that's why you must read your question very properly. And these have some certain what you say, certain tolerance. Okay, like I don't exactly know the tolerance, but suppose there's a 5% tolerance, plus or minus 5% tolerance. So the correct answer suppose was 10 ampere, but instead you did your calculations, you used fractions and various things you used, and you got the calculated answer to be 9.9 ampere. So that also is permissible. Okay, because it is within the tolerance band of plus minus 5%. So it is not required that your answer should match like 10.12 exact the point. It is not required. you should get an approximate answer which is within the range which they are permitted. So this is one type. Then also you have certain questions which are like options. You have certain options you have to say. So they say that can a permanent magnet moving coil measure? A's option is AC current. B is option is DC current. C is option both AC and DC. D is option none. Okay, so you'll have to choose the correct option. Huh? You'll have to know the theory, etc., and then you'll be able to choose the correct option. But as per my knowledge, in these type of subjects, you will mostly have this numeric answer type questions because you'll have to solve the sums, right? And once you solve the sums, then you will get an answer, and that you have to write. Okay, so that you'll have to enter. Also, you will be using, you cannot take a calculator to the exam hall. You will be provided with a calculator which is similar to the gate calculator. So those who have given gate will know what type of calculator is there. And those have certain, it is not very easy to use it. Like the calculator is in your hand, you can directly tap, 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 calculate, and you can do it fast. But with the gate calculator, it gets slow. You have to use your mouse, you have to enter, and you have to do. So it takes time, all right? So during this exam, speed is not that important because you get quite a bit of time. But in exams like GATE and all, you'll have to be a bit fast, right? Then any more questions you guys have regarding the exams, regarding the subject? You guys will also have assignments. You guys will also have assignments which you have to solve, right? So week 1 will have an assignment. There will be some certain sums, certain MCQs, which you have to provide the answer. And then you have to submit it. So that carries marks. So your assignment will carry marks. Your subjects, means your final exam also has some marks. So there is a certain ratio in which those marks get divided. I don't properly know that, but both are important. Okay, there's certain minimum you must get in your assignments as well as in your final exam also. There is some minimum amount of marks you need to get, and assignments are each week. The assignments are there. So yeah, on which forms we have to submit that assignment, sir? So actually, in the portal you go, there'll be the option for the week 1 assignment or something, and then you have to click the right answer. So question 1, you have to select the right answer, or you have to enter the value 10 or something, whatever is the answer you get. So there will be so many questions will be there. Once you enter and click and write the answer, then finally there's the submit option. Please submit. Then you have to submit, and then your answers will be recorded. Can we do like MCQ? Okay, some are MCQ. Like some of the questions are MCQ, some of the questions is numeric answer type. So in the numeric answer type, you have to provide the answer. Means it is not like a, okay, let me clarify. It is a objective exam. The objective exam. So objective exam is means you don't need to write any big large answer. They will not say explain permanent magnet moving coil. Then you have to write you'll have to draw the circuit of permanent magnet moving coil. You'll have to draw the instrument. You'll have to derive that a torque is given by this formula. The spring is torque is given by this formula. Then at equilibrium, then all that. So all those derivations are of no use. It means all those derivations are not required to be written in the assignments or in the exam. So mugging up the derivations is not going to help you in the you don't need to write the derivations. But if you know the flow of how that it is derived, it will be useful and helpful. So derivations are not going to come in the exam or anything. You don't have to write any subjective or descriptive answer that a PMMC instrument is like this, or there are 3 types of instruments who are like that. That is not going to come in the exam. You just have they'll give you a sum, you solve the sum, you get the final answer and you have to put it. You don't even have to show the steps. It is just the final answer which you get. Okay. It is just the final answer which you get. That is all that is required. So it is not required that you write all the steps, everything, you scan it and upload it. All that is not required. Right? Just the final answer is required. Okay. Any other queries? Okay. Yeah. So if you want to get a good grasp of this subject, first thing is you have to go through the lectures. Lecture videos you have to go through. Don't try to, skip the lecture video and directly go to assignments or something. That is not recommended. Go through the lecture videos. If you're finding that the lecture videos are too slow for you or very simple, you can go at twice the speed. Okay, so that you can do it. And I'd recommend is you have a notebook and whatever says drawing, whatever says deriving, etc., you write it also. It is not that a derivation will not come, drawing will not come in exam, so I don't need to draw. That is not the way to study. You should, as sir writes, as sir draws, you can do. So you don't need to write everything which sir says or draw everything which sir draws, because something sir is drawing just to improve your understanding. But you should note down what are the important points. So you go through the lecture videos and you solve the assignments and you attend these sessions, and whatever doubts you have in the week, you ask in the session. Also, there is a forum also is there. Forum also is there where you can post your questions. Okay. Hmm. So I'd like to point out that this session is being, as this session is being conducted on Zoom, there's a 40-minute limit. So once the 40 minutes is over, this meeting will end automatically. So then you rejoin. This meeting will again be started and you please rejoin this meeting. Okay. Okay. Gate exam with these notes. You can actually refer to these notes for your gate exam. But for gate exam, I would recommend using actually this whatever classes are there, many classes are there, they will have those notes, etc. That is better because that will have to the point, that will have PMMC means this is the formula, this is what you must get and you must do it. This course, NPTEL course, is basically for you to build a foundational knowledge for this measurement instruments, electrical measurement and instruments. And once you have that knowledge, then you can easily go through sums and understand and do. So these notes can be useful for building that knowledge and the foundations, but it is not enough for gate exam. Okay. For gate exam, I'd recommend getting those classes, various classes. The gate forum is there, ADC is there, all that. You buy their notes and you refer to that and you solve those things. And many of you will be giving gate exam. And the thing is, when you're solving for gate exam, preparing for gate exam and all, you should be very sure or very thorough with what you know. Okay. Suppose you solve chapter 1. Okay, chapter 1, you solve it. Then don't think you know it. Okay. You should again try solving chapter 1, again try solving chapter 1. So when you keep on solving, you will come to a stage where you know that this question means I have to use this formula, I have to use these steps, and you will get the answer. Because in gate, what is important? Speed is important, right? So you should see the question, immediately know what you must do, which is the formula, and how you must solve. Okay, that is important, and that will only come if you practice it. And when in any form of studying, what you must do is you must see a question, don't go to the solution. You must try to solve it on your own. When you try to solve it on your own, then you will get stuck. Then you will make some mistake, all that. Or then you may solve it also. And after you solve it, then you go to the solution and see what they have done, whether they have a shorter way or their way is large. or your steps are big. Okay, so from that you will get an idea. If for gate nodes, uh, see, I have not actually compared gate nodes because I've only used one node. So when I studied using gate forum. So I had taken the notes, the books, notebooks, like the books which they give of Gate Forum where they have MCQs of previous years as well as their own set of MCQs they have for 12 subjects I took. And also they gave the um, solving like tests, solving like mock tests they had, mock tests. Okay, so that I had taken. So those are important. And I use that. I have not referred to Made Easy or other things, so I cannot compare which is better. Okay, so that is one thing. And when you're giving GATE exam, it is not mandatory for you to like complete the entire syllabus of all the subjects, etc. You go through the old questions papers and you see like which exam, like which subject has more weightage. So I don't know, like you guys are all from which? Are you all from electrical or you guys are from instrumentation, etc.? You guys can tell. So you'll all be giving, when all like giving gate, you giving gate it for electrical or for instrumentation or for electronics or what? Okay, electronics and communication. Okay. So if you're giving paper in electronics and communication, you go through those previous year question papers for your subject specific, for your specialization specifically, and you see which and all subjects have more weightage. Okay, which and all subjects have more weightage, and you must give priority to that. Okay, it's not like you can uh, no study everything. It is not possible. You have limited time, so you go through which and all are very important, and whatever is very important, you must give it a lot of priority, and you must know that very well. Hmm. That is the way to go. Okay. So I'll continue with giving the summary of what you guys have gone through the lectures of Sir and what Sir has taught. Okay, I'll just give a brief summary and then you can go to the solving the sums. So next, Sir taught about damping. So why is damping required? Can anyone tell me? So there's so many of you guys are here. One of you unmute and tell. Okay. Or you can send a message and tell why do you require damping in these measurement instruments? Okay. So first of all, is damping good or bad? Okay. You can read the readings. That is something. So how many of you, so you guys, we all, we want to be healthy. We want to be fit. And yeah, to stop the point, exactly. So I'll take a measuring instrument, which I assume like most of you have used. Okay. What do you use to check your weight? Okay. What do you use to check your weight? You use a weighing machine, right? So there are digital ones also available, which will just give you the number like 29.6 kg or something. All those are there, but there are also the ones which will move. Okay. The ones which have a pointer and they move. Okay. So initially, when before you step on this weighing machine, it should be at zero. Okay, it should be at zero so that there's no error. It should show zero. And when you climb when you stand on the weighing machine, it will move, it will come here. Like if you put one leg, it will, some weight will come. Then you put your next leg, some weight will come, etc. like that. Okay, and when you finally stand, it will come at one final position. Okay, so, and how we want it to be is, we don't want this pointer to move. It should not move. It should finally come to some position and stay there. Okay, and it should be accurate and the correct position also. Okay, so if the damping which is there in that measurement instrument is poor, what will happen is, it might probably oscillate. It might show here, then after some time it might show here, it might show here, it might show here, etc. Right? So we want that instrument to come directly as fast as possible without much changes in the pointer, to come at the position which will show the correct and the true weight. Okay, so for that we require damping. Now this damping, so to damp it out, we will have a damping torque. Okay, a torque will be there, and that actually we want it to be of the form K damp into d theta by dt. Okay, so this torque will only act when there is, when the theta is changing. Only if theta is changing, this torque will act. If your theta is 0, what will be this torque? Can anyone tell? Then what will be T damp? So many of you are here. Vivekanand is there. Satyasri is there. Niranjan is there. Guys, someone is an admin over here. Sanjana is there. Manish is there. So I'll repeat my question. If my theta is 0, okay, and it is fixed at 0, what will be my damping torque? It will be 0. If my theta is fixed at, say, 30 degrees, then also what will be my damping torque? Then also it will be 0, because your theta is not changing. But if your theta is changing, like if your theta is, it is once over here, then over here, when it is not in this equilibrium position, when it is changing, depending on the rate of change, your torque will be provided. Okay, will be generated, and that torque should oppose your motion. Okay, it should oppose the motion, oppose the direction of motion, such that it will reach the equilibrium point quickly. Okay, this is there. Next, another instrument which we have studied is a galvanometer, which is basically your permanent magnet moving coil. Okay, and so PMMC is used to measure which quantities? Can anyone tell again? Vanchini, NS, Niranjan. Please let me know, Sanjeev. What is PMMC used to measure?
Current.
Yes, thank you. It is used to measure current, and basically DC current. Okay. Now it is measuring current, but we can modify it. You can modify the galvanometer such that it can measure your current. That is also true. It can also measure voltage. All right. You can make certain modifications so that it can measure current and voltage. and there will be certain sums. And when we'll do that sum, I will tell you. So there will be a coil. Okay, there will be a coil which will have some resistance in your galvanometer. It will have some, it can carry say only 1 milliampere. But suppose you want to measure current of, let us say, 100 milliampere. Then what you have to do? You will have to connect another shunt resistance. So this will carry your 99 milliampere. This will carry your 1 milliampere. And in this way, you can extend the scale or the range of your galvanometer or your PMMC. Similarly, it can also be used to measure voltage. Okay. So now, let us start solving sums. Actually, moving iron instrument can be either repulsion type or it can be attraction type. Okay, repulsion type is these two depend basically on the construction. It depends on the construction, but the basic foundation is the same. That they are going to be that the torque. Let me try. The torque is I square dl by d theta into half. Okay, so this is the torque. For it can be either attraction or repulsion type. It doesn't matter. The magnitude of the torque is dependent given by this expression, and in that manner you can use this expression to get the what you say the measure the RMS value of the current. Okay. Hmm. So when you see a question, okay, when you see a question, you guys will. So I'll assume like most of you are in engineering colleges, and you are planning to apply for GATE. Then also you will have placements. Many things will be there. So one way to improve your speed when you solve sums is, as you read the sum, you see PMMC. Okay, so you note down or that it is a PMMC. Next, you see it as 200 terms. So you note down n is equal to 200. So these are your given. These are your given quantities of your sum. Okay, n is equal to 200. They have also given the length is 1.5 centimeter. Okay, width also they have given is to be 1.5 centimeter. They have told air gap flux density is 0.9 Weber per meter square. They have told the spring constant K is spring. .75 micro Newton meter per degree. And they have told the resistance of the coil is 100 ohm. All right. So first I have whatever is given in my question, I have noted down the quantities. Now, when I solve sums, what I do is I bring them all to one unit. There's this SI, CGS, etc. I prepare SI. So length is 1.5 centimeter means I convert it into meter. I make it 1.5 into 10 raised to minus 2 meter. So many times we'll do the sum, etc., but we'll get the wrong answer because we have not considered the proper conversion, proper units. If you just directly apply a formula without making sure that the units are matched, then you will get the wrong answer. So best thing is to make the units matched. I know meter is there. I use meter. I use SI units. Okay. This I make it as 1.5 into 10 raised to minus 2 meter. The flux density is 0.9 Weber per meter square. This is the standard one. I don't need to change it. The spring constant is 1.75 micronewton meter per degree. This is mu. Mu means how much? Can anyone tell?
10 to the power minus 6.
Yeah, correct. So it will be 1.75 into the 10 to the power minus 6 Newton meter per degree. Okay, per degree. Yeah. So the deflection could be in radians, it could be in degree. So you must know in what unit it is given. You must remember that. Mismatch will result in wrong answer. So you must be careful. And then they have told the coil resistance is 100 ohm. 100 ohm is the standard. I don't need to change it. Okay, let us go back to the question. They are asking estimate the deflecting torque in micronewton meter when 4 milliampere current flows to the coil. So they want you to tell what is the deflecting torque and in which unit. That is important. It is in micronewton meter. In micronewton meter, and the current is 4 milliampere. 4 milliampere current is flowing. Okay. So now, what is the formula for PMMC? Who will tell me? What is the formula?
GANI.
It is BANI.
A बराबर area sir.
Yes, A for area. So that
L
is
गुने W.
length into width. So that will be 1.5 into 10 to the power minus 2 into 1.5 into 10 to the power minus 2. So how much is this? So how much is this? 1.5 into 10 to the power minus 2. How much is the area?
Yeah, 2.25.
Okay.
Area बराबर 2.25 गुने 10 to the power minus 4.
Okay, into 10 to the power minus 4 meter square. Okay. So now we will go to solve this deflecting torque. This is given as B. B is 0.9 Weber per meter square. Okay. Area is 2.25 into 10 to the power minus 4. What is the number? N stands for number of turns. How much is the number of turns? Oh, you guys. Okay, the number of turns is 200. Okay. This is 200. And the current is 4 milliampere. So I will write 4 into 10 to the power minus 3. Millimeter means 10 to the power minus 3. Okay. So who will solve this? So you guys solve and tell what will be the answer.
1.62 गुने 10 to the power minus 7 हो रहा है सर.
1.
minus 4 to the power minus 4 है.
Sorry?
1.6 गुने 10 to the power minus 7.
1.62.
Okay. Okay. No. 1 minute.
10 to the power 4 होगा सर, minus 4.
Actually, it should be 1.62 into 10 to the power minus 4, right?
Right.
1.62 into 10 to the power minus 4. But this is in what? What is the units of torque? Who can tell me? Torque. Like weight is in kg. Torque is in what? What is the
Newton
SI
meter, sir.
unit?
Newton meter, sir.
This Newton meter, right? But they want it in
Yes.
micro Newton meter. So how will you convert Newton meter to micro Newton meter?
Divide, sir.
Divide by how
Divide
much?
10 to the power minus 6.
Yes. So I divide it by 10 to the power minus 6. So it will come micro Newton meter. So that will be what? 1.62 into 100, right? So it comes out to be 162 micro Newton meter. Any doubts till now? Huh? Satyashri, admin, Kumara, Vanchini. Okay, it would be really nice if you guys can be interactive. Vijaya. Okay, Sanjeev.
जी सर.
So 162 micronewton meter हो गया.
जी
Now
सर.
you have to find the sensitivity in degree per milliampere.
एक बोतल काइंड निकाल जैसे बोतल समझता नहीं है तो.
Okay, so if you are not talking, kindly keep it muted, please. And when you are giving the answer, you can unmute. So sensitivity. You have to find the sensitivity in degree per.
Sensitivity of theta over I, sir.
Yes, this theta upon I. So we know BANI is equal to K spring into theta. Now my sensitivity is given by I upon theta. So that is equal to K spring upon BAN. What is your spring constant? K spring is 1.75 micronewton meter per degree. So I will use 1.75 into 10 to the power minus 6. This B actually is 0.9. Area is 2.25 into 10 to the power minus 4. N is 200. So can you calculate and tell me what is the answer sensitivity? Sanjeev, Niranjan, Manish, admin, Mutasiri, Anjita.
रोड पे खाली बची है. वैसे कभी नहीं करूँगी. बस मस्त आवाज होगी. सोन से तो नहीं करूँगी.
So 4.321 over minus 0.5.
Sir, 40.5 written.
4.32 into 10 to the power minus 5, right?
जी sir.
Right, sir.
Okay. What is the unit of this?
यहाँ पे मिलेगा.
Sensitivity का no unit होगा क्या sir?
மோட்ல போடு ஏரோப்ளேன் மோட்.
Okay.
Hello sir.
Yes.
Sir, sensitivity is SA equal to theta by I.
Yeah. That's what I realized.
Radian per ampere, sir.
Okay. Kindly mute. If you are not talking, please mute. If you are not
Sir, radian per ampere.
sorry, 1 minute. Okay, fine. So now tell me. So first of all, I made a mistake. This is wrong because sensitivity is actually I by theta. This is coming out to be wrong. No, sensitivity is degree by milliampere. So sorry, your sensitivity is actually theta by I. Okay, that is BAN upon K spring. तो सिर्फ उल्टा हो जाएगा. It will just become the opposite. So what will this be?
2.31 power 10 power 4, sir.
So this 2.31 into 10 to the power 4. Okay. But what is the unit of this sensitivity? Someone was telling something for the unit. Can anyone tell? Someone was saying something.
Sir, you told degree per milliamps, eh?
You told degree. This will be degree per amp. Okay. But we wanted it in degree per milliamp. So what will we do?
Multiply by 10 power minus 6.
Right, sir. Right, sir.
Multiply by 10 to the power minus 6.
-3, sir.
10 minus 3, sir. Milli minus 3.
Yes, yes. So what you do is you do it as 2.31 into 10 to the power 4. So sometimes it gets confusing. What I do is this is in degrees in the numerator. The denominator is ampere. You wanted to make it milliampere. So you know 1 ampere is 10 to the power 3 milliampere, right? So this becomes 10 to the power 3 milliampere, right? So this becomes 2.31 into 10 to the power 4 into 10 to the power minus 3 degree per milliampere. That becomes 2.31 into 10 degree per milliampere, or that is 23.1 degree per milliampere. Okay, so why is this in degree and not in radians? Usually theta b is considered radians. Why is it in degree? Many of you are there. Mita Sargi, Vivekanand Kumar. Why is
Excuse me, sir.
yes.
Sir, if we equate the deflecting torque into controlling torque, then T is equal to K into theta. So if you want to calculate the theta equal to BANI divided by K.
BN by I, yes. By K.
BANI divided by K, sir.
Yes, correct. Sorry?
Is it correct or not, sir? We have taken theta equal to BAN divided by K.
BANI divided by K. Yes, correct.
Is it correct, sir?
Yes, correct.
After calculating theta, we need to substitute that value in that sensitivity.
No. See, here you don't know theta. You don't know theta, right?
Yeah.
You can calculate theta as well. But instead, why to do two calculations? Instead, what we know by sensitivity is theta by I. So I know
yeah, sir.
is BAN by K spring, right?
Okay. This is the correct procedure. Is this correct procedure, or after calculating just by you equating those, then we will get the formula theta for BANI divided by K?
Yes. Yeah, correct. Both ways you can do. You should get the same answer.
Both ways we can do, sir.
Yeah. Both ways you get the same answer.
Okay. Thank you.
Okay.
Okay, thank you.
Okay. Then one more thing is your K spring, because the unit of K spring was case spring, if you see, it is 1.75 micronewton meter per degree.
Yes,
It is in degree. That is why you don't get the angle in radians. You get the angle in degree. Okay. So this you must take into account. If it was written in radian, then it will come in radians.
okay.
Okay. Yeah.
Okay.
So anyone has any queries still here, or we can proceed to the next part? Okay. Please be interactive. Please ask questions. Yes, yes.
Excuse me, sir. Sir, what's the final answer for the sensitivity, sir? Can you repeat it again?
Can I repeat what? Hello? Mr. Zagi, you said something. Last part I couldn't hear properly. Can you repeat?
Can you repeat the sensitivity answer, sir? Final answer.
Okay, sensitivity final answer. Okay.
Oh, yes, sir.
It comes, okay. So, by calculation, we got it 2.31 into 10 to the power 4 degree per ampere. We want it to be in terms of milliampere. So that is why I know 1 ampere is equal to 1000 milliampere. So I write it as 10 to the power 3 milliampere. Then this 10 to the power 3 goes to numerator, becomes 10 to the power minus. So, and this unit is degree per milliampere. So then once we convert in etc., we get it as sensitivity is 23.1 P per milliampere. Okay.
Okay, okay, fine, sir, fine, sir.
So I'll proceed to the next part of the question. Okay. They say the pointer stays at 0 degree when no current is passed, and the pointer can move up to 90 degree rightmost end of the scale at max. Estimate the full scale deflection in milliampere. Okay. So now they have told us that theta max is 90 degree. So we need to find the current max. Okay. So now we know that BANI is equal to K spring into theta. We want to find I. So I is given by K spring into theta upon BAN. So what is your K spring? K spring is 1.75 to 10 to the power minus 6 Newton meter per degree. Okay. So it is 1.75 into 10 to the power minus 6 Newton meter per degree. Your maximum deflection is 90. So it is 90 degree divided by B is your 0.9 Weber per meter square into your area is 2.25 into 10 to the power minus 4 meter square into a number of turns, that is 200. Okay, so what gets cut? Your meter square gets cut, your degree and degree gets cut. So this is, you must make sure that they are in the same units. Then only they can properly get cut. Otherwise, they do not, and you will get the wrong answer. So that is something I'm stressing a lot, but that is something we sometimes forget to do. Okay. So now you get your current I is 1.75 into 10 to the power minus 6. Now you can get rid of all these Newton meter, all this Weber, all that you can leave because they are in the standard SI. So it will effectively come out in terms of ampere. Okay. Now this is 0.9 into 2.25 into 10 to the power minus 4 into 200 into 90. So what is this? Can anyone calculate and tell me?
3.88 into 10 to the power minus 3.
3.88 double 3.88 into 10 to the power minus 3. Sorry, will you repeat?
Yes, sir. 10 to the power minus 3.
10 to the power minus 4. Okay.
Minus 3, sir.
Oh, 10 to the power minus 3. Sorry. Sure. What about others? Did you guys get the same answer? Okay. Please have your calculators with you. Please do the
Yes, sir.
Okay. Thank you. So we got it to be 3.88 into 10 to the power minus 3 ampere. But in the question they asked in milliampere. Okay, so what will it be then in terms of milliampere? Huh?
1000 से मल्टीपल करना पड़ेगा ना।
हाँ सही बात है 3.88 10 to the power minus 3 10 to the power 3 ampere milliampere sorry. So your current becomes 3.88 milliampere. All right. So any doubts?
No doubt, sir.
Okay.
No, sir. The answer should be 10 to the power minus 6 milliampere, sir.
10 to the power minus 6.
You are multiplying 10 to the power minus 3 into 10 to the power minus 3.
I'm so sorry. I'm so sorry. It's actually 10 to the power 3.
Yes.
Okay, thank you for pointing out. So it is 3.88 milliampere. So we want the next part is, it is found that the instrument exhibits critically damped oscillations when the resistance of the circuit external to the moving coil is 100 ohm. Find the critical damping constant in nano-Newton meter per degree per second. Okay, let me actually snip it. Okay, so this is the numeric answer type question. So you can see there's a box. So you can see that there's a box. So in this box, you'll have to enter your answer, right? This is just a printout of the thing, so you cannot enter here. So this is your fourth question. Now, in damping, there's something known as critical damping. In critical damping means there will not be any overshoot or undershoot, and that is made up required. Okay. So now, they have given that the R external is 100 ohm. Also, we know that R of the coil was given in the main part of the question to be 100 ohm. They are telling find out the critical damping constant. Okay. Yes, Manish.
Sir, that previous question answer should be 3.88 10 to the power minus 6 milliamps, sir, or is it because amps and milliamps you have to multiply the 10 to the power minus 3, sir? Am I correct?
No, because
from amps to milliamps you are converting, no?
You know, 1 ampere is 1000 milliampere, right?
1 ampere equal to 1000 milliampere.
No. So let us say.
Yes. Okay. You are correct. 1 bar equal to 10. Okay.
Okay. Yeah. So this milli, nano, micro, kilo, mega, all these are important. Okay, they cannot be ignored. And here in this exam, you don't get any marks for steps. Your steps may be right, formula may be right, but if your answer is wrong, fully 0. Either you get it all right or all wrong. So that is why there is very less margin for error. So you must take care of the units very carefully. Now, for this damping constant, the formula is given by BAN the whole square upon RC plus R external. Okay, this is the formula. So now, actually, this you guys will be knowing 0.9 into area is 2.25 into
सर
10
ये
to the power
RX
minus
क्या होता है?
ये REX वो है एक्सटर्नल रेसिस्टेंस जो जो
लोड
ये
रेजिस्टेंस.
हाँ एक्सटर्नल ये गैल्वेनोमीटर के बाहर जो रेसिस्टेंस वो देखता है उसको बोलते हैं एक्सटर्नल रेसिस्टेंस REX. ठीक है. हाँ इधर RX है वो REX में लिख दिया. ओके मतलब सपोज दिस इज योर इंस्ट्रूमेंट, उसके एक्सटर्नल जो रेसिस्टेंस है REX या RX. ठीक है. आपका पूरा बड़ा भी नेटवर्क हो सकता है पर इफेक्टिवली जो रेसिस्टेंस दिखता है ये इंस्ट्रूमेंट को वो होता है आपका REX. So this RC previously it is given 100 and REX also is 100. So what will be the value of this?
(8.20 into 10 to the power minus 6).
Sorry, this should be square root. What about others? Others are not calculating. Sanjeev, Manish, Niranjan, Vanchini, Vaishnavi, Mara, Mijagi, NS, Vivekanand.
Got the same answer, sir.
Oh, okay, you can tell, so we know that everyone is solving. So this is given in Newton meter per degree per second. Okay, but now they want it in nano Newton meter per degree per second. So what is nano? Nano is what? 10 to the power minus 7, 10 to the power minus 6. What is it?
10 to the power minus 9.
Okay.
Good, sir.
10 to the power minus 9. So it will be 8.20 into 10 to the power minus 6. Okay. Yes, 10 to the power minus 9. So how simple way to say 1 Newton meter is equal to 10 to the power 9 nano Newton meter, right? Any confusion in this? What about others? 1 Newton meter is 10 to the power 9 nano Newton meter.
Newton meter, sir.
हाँ
1 nanometer बराबर 10 to the power 9 Newton meter. Minus 9, sir.
no. That is why you are making it wrong. मतलब 1 Newton meter is equal to 10 to the power 9 nano Newton meter. Okay. So then you have to substitute here 8.20 into 10 to the power minus 6. into 10 to the power minus 9 nano Newton meter per degree per
जी सर
second.
जी सर
Wait, हाँ. तो वो हो जाता है, that becomes 8.2 into 10 to the power 3 nano Newton meter per degree per second. That becomes 8,200 nano Newton meter per degree per second. Any doubts? Niranjan, any doubts? Okay. If not, we'll proceed to the next question. Now they are saying, estimate the required shunt resistance in ohm to convert this PMMC instrument into an ammeter of range 0 to 100 milliampere. Okay. Okay, let us snip it. You guys are able to see the question, right? So we want the range I full scale deflection to be 100 milliampere. Okay. But, and we also know that the coil resistance is 100 ohm. But we have found out in a previous question that my theta max is 90 degree and my I max comes out to be 3.88 milliampere. That is, my I max is equal to 3.88 milliampere. So we have this instrument, it has its own internal resistance RC, and the current that it can pass maximum is 3.88 milliampere. But we want to measure current of 100 milliampere. So what do we need to do is, we need to connect a shunt resistance, R shunt. Okay. And how much will be the current through this shunt resistance?
100 minus 3.8.
96.212 sir
96.12.
96.12 millimeter.
Okay. So how much is this R shunt which is required? So there is a rule known as current division rule, right?
जी ammeter
I shunt is equal to I into RC divided by RC plus R shunt, right? So how much will you get R shunt to be? Can anyone calculate and tell me? Or there is an easier way. there is a voltage drop over here, right? How much is that voltage drop? It is 3.88 milliampere into 100 ohm. That is 3.88 into 10 to the power minus 3 into 100 volt. That comes out to be 3.88 into 10 to the power minus 1. That is 0.388 volt. Now we know I shunt is 96.12 milliampere. So your R shunt is equal to V upon I shunt. That is equal to 0.388 divided by 96.12 into 10 to the power minus 3. So how much is that?
$4.037, sir.
Yes, it is 4.037 ohm. Okay. Yeah. So now it comes to the question, which is there are multiple options. This is an MCQ type question. They are telling us to select the correct statement. They are asking the above ammeter. Now I have changed. There was the galvanometer, and we found out that if our external resistance is 100 ohm and the coil resistance is 100 ohm, then we will get a critically damped response. Now, when we have converted into an ammeter with such a range of 0 to 100 milliampere, they are asking whether the response will be underdamped, whether the response will be overdamped, whether the response will be critically damped, or dependent upon the external circuit. What will be the answer? So you are saying the C, but let us see why they are saying it could be the. It is given the correct answer is B. Okay, so let me explain. We know that the damping is equal to minus BAN squared by RC plus R external. Okay. And then we found out, that at this particular damping, it was giving critically damped. For this RC, for this R external, it was giving critically damped. Okay. But now what is happening is my RC is changing. Why is my RC changing? Because initially it was just RC. Okay. Now it has become RC and R shunt. So my RC new, will my RC new be bigger than RC or smaller than RC?
Bigger, sir.
Sorry? My effective RC new is RC parallel R shunt. Okay?
A smaller value होगा sir.
Yes. So my RC new
4.4
is
हो
less
गया
than
उससे
RC.
कम ही.
Pehla, first RC was 100 ohm. Your RC initially was 100 ohm, right? Now your RC new will be 100 parallel your R shunt, that is 4 ohm. And now when you do any parallel combination of resistors, your effective resistance will be less than the least of all the resistors. So your RC new has to be less than 4 ohm. Okay? You don't even need to calculate this 100 parallel 4 and do all that. You know, you can say that your RC new is less than 4 ohm. So if my RC new, so it is established that my RC new is less than 4 ohm. It was initially 100 ohm. Now it is reduced to 4 ohm. So what will happen is your RC plus R external effectively, has it increased or reduced? Because your RC has reduced, your RC plus R external also would have reduced. So if your denominator has reduced, what happened to your damping? Your damping has increased. Right? So earlier it was critically damped, now it will become over damped. Okay. Any queries?
सर ये सर ये आरसी चेंजिंग के नीचे सर आरसी क्या लिखे हैं?
RC new, RC new.
अच्छा आरसी नहीं,
मतलब ये RC new क्या है? जिस effective RC now. Yeah. So I'll go to the next question. Now they are telling that we want to convert this PMMC instrument into a voltmeter of range 0 to 25 volt. Okay. It should V max will be 25 volt. If you remember, your current full scale of your original instrument was 3.88 milliampere. And your coil resistance RC was 100 ohm. So your V max old was 100 into 3.88 into 10 to the power minus 3. It was 0.388 volt. So it can only measure voltage up to 0.388 volt earlier. Okay. But now, what are we doing? Earlier, what it was RC, it was on deflection. This was earlier an instrument and it could measure voltage up to 0.388 volt. Okay. Now we want it to measure up to 25 volts. So what we will do, we will connect RC is there, this coil will deflect, but there will be an R series resistance. Okay. And we want this voltage to be 25 volt. Okay. Here your current max, current full scale was 3.88 milliampere. Here, what will be your current full scale which is required? Can anyone tell? Manchini or Mutazagi, Niranjan, Manish, Yemula, Aruma, Junaid, what will be your current full scale? The current full scale of this instrument and this instrument will remain the same because that galvanometer has not changed. It is mechanical construction has not changed. The coil and everything in the galvanometer has not changed. So maximum current it can carry will still remain 3.88 milliampere. So the only thing is externally I have connected a series resistance R series. And I will be measuring the effective voltage across these 2 points. Okay, that I want it to be 25 volt. So now what should be my R series? So my RC plus R series into this I full scale should be equal to 25 volt. So my RC plus R series will be 25 by I full scale, that is 3.88 milliampere. So what will be my R series? Okay. Who will tell me? Hello. So many of you guys are there.
RC plus R सीरीज 6443.298 आ रहा है.
So this is 3.2 ohm.
2989.
हाँ चलेगा. So what will be your R series? You know your RC is 100 ohm. So your R series will be how much?
Six.
Sir, 6343.2.
Yes, so it will be 6343.2 ohms. Okay?
जी sir.
Yeah. So this is the answer. So similarly, they told you can check with what will happen for voltmeter, the damping, etc. That also you can check. So now we will go to the 9th question. Okay. So now, this is the question. They have the electrodynamic. So there's an electrodynamic ammeter. Okay. The mutual inductance is given by this 500 into sine into theta minus pi by 9 microhenry. Okay. And they're given theta is in watt? It is in radian. That you must note down. Okay. So your M also actually I write it as 500 sine theta minus pi by 9 into 10 to the power minus 6 Henry. This is the SI unit. I bring it to SI unit for sure. Theta is in radian. They told the spring constant K spring is equal to 0.15 micronewton meter per degree. Okay, this is in degree. So now they're telling find the deflecting torque in micronewton meter when the meter deflection is 40 degree. So now your theta is given by 40 degree. Okay. So what will be your case? Your T deflecting is K spring into theta. This let me bring it in 0.15 into 10 to power minus 6 Newton meter per degree. Micronewton meter is equal to 10 to power minus 6 Newton meter. So that will be equal to 0.15 into 10 to the power minus 6 Newton meter per degree into 40 degree. So I cancel this degree by degree, get cancelled. So it is 0.15 into 40, that is 1.5 into 4, that is 6 into 10 to the power minus 6 Newton meter. Okay. But they want the answer in micro Newton meter. That will be 6 micro Newton meter. Because 1 Newton meter is 10 to the power minus 6 micro Newton meter. Any queries in this?
No, sir.
Okay. So now, next we have to find the meter current. Therefore, the deflection is 40 degree. We want to find current. So we know for electrodynamic instrument T equal to K theta is equal to I square into dm by d theta. Right? My T deflection I know, that is 6 into 10 to the power minus 6 Newton meter. My I square is unknown. I know I need to find d by, what is my m? My m is given by 500 into sine theta minus pi by 9 into 10 to the power minus 6. So that is equal to 500 into 10 to the power minus 6 into sine of theta minus pi by 9. Theta minus pi by 9. Okay. So what is the derivative of this? Who will tell? Six into 10 to the power minus 6 is equal to I square. 500 is a constant, 10 to the power minus 6 is a constant, so it comes out 510 to the power minus 6. What is the derivative of sine?
Cos theta.
So it becomes cos of theta minus pi by 9. But the angle
Right, sir.
theta which I must substitute is 40 degree. Okay. So now this 10 to the power minus 6, 10 to the power minus 6 get cancelled. So it becomes 6 upon 500 is equal to I square into cos of theta. I have to put 40. So I put 40. But theta should be in radian. So we have to convert it into radian. I have to make it into pi by 180. And this is minus pi by 9. So what is this? 6 upon 500 is equal to I square. What is this? 40 into pi by 180?
2 pi बट्टी 9 minus pi बट्टी 9 pi बट्टी 9 होगा सर.
So it becomes cos pi by 9. Okay?
जी
So what
20
is
डिग्री हो गया.
cos 20 degree? Okay, so what is cos 20?
जी सर. cos 20 डिग्री बराबर सर दे रहा है 0.9396.
So this is 0.9396.
जी सर.
So what is your I then? So what is your current? Okay, someone is not talking. Please let them know. Okay. Achha, one more thing I forgot to tell you guys is these all will be uploaded on YouTube. Okay. And there will also be a drive where I will upload these notes, which you can refer later. So I'm pasting that in the chat. This is the drive link. And this is the YouTube link. Okay, my YouTube channel from where you can get the video. The video will be uploaded to. Okay.
Okay, sir. Okay, sir.
So this is the current which we have found. Okay. Now we will go to the next question. So they told to find a current in milliampere. Okay, so milliampere. So this has to be converted to milliampere. So what will be 0.113 into 10 to power 3 milliampere. So it is 113 milliampere. Okay. Now we'll go to the next question. So they have told that it is an electrostatic instrument. Okay, and we will be using it to measure voltage. So there are two semicircular discs. So can anyone tell what is a semicircle? What do you call a semicircle?
Circle means 180 degree का ये half circle.
Now, this circle is full 0 to 360 degree.
वो 360 degree का होता है.
This is 360 degree, but a semicircle is half. So like these half plates are there. Okay.
180 degree.
So now there is a stand. There is something which is fixed. Okay, 180 degree curve. Same, they all are the same. But another is there which can move. Okay. So now, depending on whether it is fully aligned या opposite, मतलब अगर आप ऊपर से, if you see it from top, it can look like this. Okay, this can be your fixed plate, and this could be your deflected plate. Okay, your deflected plate could look like this. Let me draw in a different color. So this could be your deflected plate, or it could be like this. This could be your deflected plate, and this could be your fixed plate, or it could be like this. This is your deflected, this is your fixed plate, and your deflected plate is like this, right? So depending on how much area overlap, depending on how much overlap is there, that will determine the capacitance, and that will determine how much your deflection will be. Okay, how much of voltage is there. So this overlapping area between them can change. They have told the radius of each is 6.5 centimeter, and the distance between them is 9 millimeter. So this distance is 9 millimeter, and the radius of the plate is 6.5 centimeter. Okay. So now they told string constant is 0.2 micronewton meter per degree. All right. So let us write down. We know R is 6.5 centimeter. That is 6.5 into 10 to power minus 2 meter. My distance is 9 millimeter. That is 9 into 10 to the power minus 3 meter. My what else is given? K spring. 0.2 micronewton meter per degree. 0.2 micronewton meter per degree. That is 0.2 into 10 to the power minus 6 Newton meter per degree. Right? This is given. Now we know the P deflection is equal to half V squared into dc by d theta. And what is your capacity? C is the capacitance. Okay, so we know the capacitance is given by area into the permittivity by the length. Okay. So now this area is the overlapping area. Right? And how much is that area? That area can be 0. It can also, if it is like this, your area which is overlap is 0. If it is like this, your area overlap will be equal to the quarter of the circle. We know that the area of a
20 degree.
circle is pi r square. But in this case, it will be pi r square by 4.
4.
Okay. And when it is fully overlapped, when there is a complete total overlap, it will be pi r square by 2. Because it is a semicircle, right? It is this overlap area. So it will be pi r square by 2. Okay. So that means your area is equal to r square into your overlap theta, and your theta can range between 0 to pi.
180.
So wait a minute. There is a mistake, sorry. So area of the circle is pi r square, but in this case it is pi r square by 4. Full is area is pi r square by 2. Okay, full is area is pi r square by 2. So your area is pi r square by 2 into theta. Acha, sorry. Your maximum area is pi r square by 2. But the actual area will be equal to your theta into r square by 2 divided by pi, right? Hello?
Yes, sir. Yes, sir.
Mhm. Wait, let me just verify this.
pi r square by theta होगा क्या सर?
मैं देख रहा हूँ. In this case, it is जब complete overlap है, it is pi r square by 2. In this case, it is 0. When it is like this, it is pi r square by 4. Okay, so a better way is When the deflection theta is 0 degree, my area is 0. When the deflection theta is pi by 4 or 45 degree, my area is pi r square by 4. Right? Then when my deflection theta is 90 degree, my area is pi r square by 2. And when my deflection theta is 180 degree, अच्छा, here I am making mistake.
Pi r square by theta हो जाएगा.
Okay, okay. So the mistake is my area, maximum area. My maximum area can be when this complete thing is overlapped. Okay, that is pi r square by 2. Okay, pi by 2 r square. So in this case, my area is actually equal to, if you see what is my theta in this case is 180 degree. So the area, overlap area is actually given by theta, that is pi, into r square by 2. Are you getting this?
Yes, sir. Yes,
Okay.
sir.
Area is actually theta r square by 2. Okay. So now my capacitance is what? It is area into epsilon by L. That is theta r square by 2 into epsilon by L. Okay. So now my dc by d theta is equal to r square into epsilon by 2L. Okay. So this r square is, anyway, epsilon will be epsilon naught because it is in, what you say, in air. So it is 2 into L, or the distance. So now, what is the T deflection? T deflection is half v square dc by d theta. So my T deflection is half into v square into dc by d theta. So can anyone tell what is R? R actually found out to be 6.5 centimeter. So that will be 6.5 into 10 to the power minus 2 square. What is epsilon naught? Who knows? Can anyone tell?
8.85 into 10 to the power minus 12.
8.85 into 10 to the power minus 12. And distance is 9 millimeters. So 2 into 9 into 10 to the power minus 3. So this comes out to be, what does it come out to be? This actually is 10 to the power minus 2. Okay. What is the answer? Okay, the answer comes out to be 2.07 into 10 to the power minus 12. So can anyone verify and tell me that you are getting the same answer? Okay. Okay. And what have they given us? They have told we have to find the deflecting torque. If 1.3 kilovolt is applied, okay, they have given us the voltage. So it is half into 1.3 into 10 to the power 3 square into dc by d theta is 2.07 into 10 to the power minus 12. So how much is this? Hello. So this becomes 1.749 into 10 to the power minus 6 Newton meter, or it can also be written as 1.749 micro Newton meter. Okay, any queries? Any doubts?
No, sir.
Okay. So we'll stop at this. It's already become 8. So if you have any doubts from the entire session, you can ask me, or we can end here and then we will meet next week and we will solve questions related to week 2. Also, you can give
Okay,
your
thank you.
feedback, like what would you prefer? Should I do the recap and then start sums, or should I directly start with the sums? So like what would be your best way? What would be the best way to proceed?
Thank you, sir.
Okay, okay.
Hello, sir.
नमस्कार सर. सर
Hello.
नमस्कार.
हाँ, ठीक है. नमस्कार. बोल रहे कुछ?
It's not boring, sir. It's okay.
Okay, okay. Thank you. Okay.
Hello, sir.
Yes, yes, yes.
Excuse me, sir.
Yes.
Hello, sir. Excuse me, sir.
Yeah.
Where we can get a link, sir? Recorded link.
Link I actually put on the chat. Let me again put actually. Links over here. So both I'm pasting it. So the drive link I put and the YouTube link also is there. Okay.
Okay.
Yeah. So drive link is where I'll upload these notes, and YouTube link is where is my channel where I will upload this video. Okay, the video I will upload after some time. It takes some time to process, edit everything. And these notes also I will upload on the drive. And you can access these notes. Okay. So you can just save these links. You can save it in your PC or somewhere. In some document you can save. So you can access these links later. Also, they will also share these links with you. But you can also use these. Any other queries?
No query, sir.
Okay. If there's nothing, we can end the meeting. Okay. So thank you for joining. Thank you for listening.
Okay, thank
Thank
you,
you,
sir.
sir.
Yeah. But please make it more
Thank you,
interesting.
sir.
Bye.